Hello everyone, welcome back to our AWS Cloud Practitioner Essentials series. In this lesson, we are going to focus on how Amazon EC2 instances store and access data. More specifically, we will compare two block storage options associated with EC2, Amazon EC2 Instance Store and Amazon Elastic Block Store, commonly known as Amazon EBS, although both provide the block level storage, they serve very different purposes. This store provides fast local storage that is physically connected to the server hosting the EC2 instance. However, the data is temporary. Amazon EBS, on the other hand, provides persistent managed store that can continue to exist even when the EC2 instance is stopped. This distinction is extremely important both in real AWS architectures and on AWS Cloud Practitioner Exam. During this presentation, we will explore how block storage works, when instance store is appropriate, why EBS is used for persistent data, and how EBS snapshots support backup and recovery, and how to choose the correct option for a particular workload. Let's begin by looking at the resources and EC2 application needs. Why EC2 application need storage when we launch an Amazon EC2 instance? We are creating a virtual server in AWS Cloud. Like any physical computer, the server needs several fundamental resources. The first resource is CPU. The CPU executes the instructions generated by the operating system and applications. For example, it may calculate the total value of a line order, process a financial transaction, or run an analytics algorithm. The second resource is memory, also called RAM. Memory contains the active data that application need while they are running. It is extremely fast, but is normally temporary. When a computer is powered off, the information in RAM is lost. The third resource is the network. Networking allows the EC2 instance to communicate with the customers, other servers, databases, AWS services, and systems located outside AWS. Finally, the instance needs storage. Storage holds the operating system, application files, database files, logs, documents, and other information that must be processed and preserved. An important distinction is that memory and storage are not the same thing. Memory is the temporary working area of the computer. Storage is where information is kept for processing or long-term retention. In this lesson, we are concentrating on block level storage. EC2 application may use block storage for the operating system, business applications, databases, file systems, temporary cache, data processing workspaces. The key question is not simply where can I store the data? The more useful question is, does the data needs to be permanent, or can it be temporary and recreated? That decision will help us choose between Instant Store and Amazon EBS. Now we're going to see block level storage, the Incremental model. To understand the EC2 storage, we first need to understand the basic idea of block storage. Block storage divides data into small manageable units called blocks. A file is ultimately a sequence of bytes. Those bytes are mapped to different blocks on a disk. For example, imagine a file distributed across 6 blocks, blocks 1, block 2, block 3, and so on. If one small part of that file changes, the storage system does not necessarily need to rewrite every block. It can update only the blocks that contain the changed information. This is one reason block storage is efficient for applications that make frequent small updates. Consider a database containing 100 gigabytes of customer information. Suppose one customer changes their mailing address. It would be extremely inefficient to rewrite the entire 100 gigabyte data file. Instead, the database updates only the relevant pages and blocks containing that record. This behavior is ideal for transactional databases, operating system, enterprise software, frequently modified files, traditional file system. Block storage also feel like a normal disk to operating system. The operating system can partition it, format it, create a file system, and mount it. The application can then use familiar paths such as /data, /database, or a Windows driver letter. Another important benefit is low latency access. Latency is the time required to complete a request. Applications such as databases often perform thousands of small reads and writes. Even a small delay in each operation can negatively affect the overall application performance. The most useful mental model is this. Block storage behaves like a hard disk or SSD connected to computer. In AWS, that virtual computer is an EC2 instance. So now we're going to slide 4, Amazon EC2 Instance Store. Amazon EC2 Instance Store provides a block storage that is physically attached to the host computer running in the EC2 instance. This is important because an EC2 instance is virtual machine running on an underlying physical server inside an AWS data center. Certain EC2 instance types have local disks installed directly in that physical server. Those disks are presented to the EC2 instance as instance store volumes. Because the storage is physically close to the instance, it can provide extremely fast input and output performance. However, there's a major limitation. In this case, instance storage data is not persistent. The storage is connected to the physical host, not permanently connected to the virtual EC2 instance. If the instance is stopped, terminated, or affected by a failure of an underlying host, the data stored on the instance store can be lost. Why does stopping the instance cause this problem? When a stopped EC2 instance is started again, AWS may place it on a different physical host. The new host does not contain the local disk from the original server. A useful analogy is temporary disk in a shared office. You may leave documents inside the desk drawer while you are working. However, when you return the next day, you may be assigned a completely different desk. The document left in the previous drawer don't automatically follow you. Instance store works in a similar way. It is also important to understand that instance store is not a standalone AWS storage service. You do not normally create an instance store volume independently and later decide where to attach it. Instead, it is available only with the selected EC2 instance types that include local storage. The core description of instance storage is fast, locally, and ephemeral. Ephemeral means temporary and not designed for permanent data retention. Now we're going to analyze instance store benefits and use cases. Although instance store is temporary, it can still be extremely useful. The deciding question is, can the application afford to lose this data, or can the data be recreated? When the answer is yes, instance store may be an excellent choice. The first benefit is that it is automatically available with the many compatible EC2 instance types. The local storage is already part of our underlying host configuration. The second benefit is cost effectiveness. Instance store does not generate a separate EBS storage charge. Its cost is included in the price of EC2 instance type. This does not mean the storage is completely free. You are still paying for a EC2 instance. However, there is no additional standalone volume charge for the local instance store capacity. The third major benefit is performance. Because the storage is directly attached to the physical host, it can offer very low latency and high input-output performance. This makes it attractive for temporary workloads that need to process large amounts of data quickly. Let's look at the three common use cases. Okay, cache. A cache store stores a temporary copy of data that exists somewhere else. For example, an application may keep a frequently requested product information in a local cache. If the cache disappears, the application can retrieve the original information again from a database or another persistent source. Buffer is a temporary waiting area. For example, an application may receive data faster than it can process it. The data can be held temporarily in a buffer until the processing system is ready. Scratch space is temporary working area used for calculation of data processing. Imagine an EC2 instance converting a very large video. In original video is safely stored in Amazon S3. The EC2 instance downloads the file and uses instance storage for temporary video fragments and processes in file. When the conversion is complete, the final result is uploaded back as tree. If the temporary instance stored data is lost, the process can be repeated from the original video. The rule to remember is simple. If the only copy of data must survive, do not use instance store. Instance store is appropriate only when the data is temporary, replicable, replicated elsewhere, and easily recreated. Now we are going to see and analyze Amazon Elastic Block Store. Amazon Elastic Block Store, many applications cannot tolerate losing their data when an EC2 instance stops. A database, for example, must preserve customer records, payments, inventory information, and business transactions. This is where Amazon Elastic Block Store or Amazon EBS becomes important. Amazon EBS provides persistent block level storage volumes for Amazon EC2 instances. The easiest mental model is to imagine that EBS volume as a virtual external hard drive. The EC2 instance is the virtual computer, and the EBS is the persistent disk connected to that computer. Unlike instance store, EBS is not directly tied to the local disk of the physical host running EC2 instance. It exists as a separate AWS resource. This means that the data can continue to exist when each EC2 instance is stopped and started again. EBS volumes can also be encrypted, backed up, resized, modified for different performance requirements. Detached from one instance, attached to another compatible instance. This separation between compute and storage creates operational flexibility. Suppose an EC2 instance has a hardware or software problem. The data volume can potentially be detached and attached to a replacement instance in the same availability zone. Similarly, if the organization needs a more powerful EC2 instance type, the persistent EBS data does not have to be recreated from the beginning. The central idea is Amazon EBS provides persistent virtual disk for EC2. It is normally the appropriate choice for operating system volumes, application files, databases, business records, file systems, information that must survive a stop and start cycle. Slide 7, how an EBS volume used using an EBS volume. It is generally involves several steps. Step 1, define the volume. First, we define the characteristics of the volume. These characteristics may include the capacity, volume, type, performance level, encryption, availability zone. The correct configuration depends on the workload. A development server may require only moderate performance, while high volume transactional database may require significantly higher IOPS. Step 2, provision the volume. Provision means creating the EBS volume as an AWS resource. Once created, the volume exists separately from the EC2 instance. Step 3, attach the volume. The volume is then connected to an EC2 instance. An important rule is that the EBS volume normally attaches to an EC2 instance located in the same availability zone. For example, a volume in US East 1A normally attaches to an instance in US East 1A. It cannot simply be attached directly to an instance in US East 1B. Step 4, format and mount a new block. Storage volume is not automatically ready to hold files. The operating system may need to create a file system such as X4, XFS, or NTFS. The volume is then mounted at a location such as /data or assigned a Windows drive letter. Step 5, write application data. Finally, the application is configured to store its information mounted volume. This might include a database file, transaction logs, uploaded documents, application data, operating systems file. if we need the data in another availability zone, we normally create an ABS snapshot and use that snapshot to create the new volume in the destination zone. Within a region, snapshots are regional sources rather than being tied to a single availability zone. For a different AWS region, the snapshot can be copied to the region before creating the new volume. Persistence, what happens when EC2 stops? This slide explains the central difference between instance store and EBS. Let's begin with the instance store. While the EC2 instance is running, the application can write information to the local instance store volume. That information exists on the physical host currently running in the instance. However, if the instance is stopped or terminated, that local data disappears. When the instance is started again, it may run on a different host where the old local disk does not exist. Now compare this with Amazon EBS. While EC2 instance is running, the application writes data to a separately managed EBS volume. When the instance is stopped, the EBS volume remains. When the instance starts again, the data can still be accessed. The persistence makes EBS suitable for information that must survive changes in the compute environment. There is one important nuance involving instance termination. When an EC2 instance is stopped, its EBS volume normally remain available. When an instance is terminated, the result depends on the volumes. Delete on termination setting. The root EBS volume is commonly configured to be deleted automatically when the EC2 instance is terminated. Additional EBS data volumes may be configured to remain. Therefore, this is not always accurate to say that every EBS volume automatically survives termination. A more precise statement is, EBS supports persistent storage, but the volume's lifecycle behavior depends on its configuration. For exam questions, pay carefully attention to words such as stop, start, terminate, root volume, delete on termination. The simplified memory rule remains instance store is temporary, EBS is persistent. EBS performance and cost tuning. EBS performance cost tuning. Not every application has the same storage performance requirements. For that reason, Amazon EBS provides different volume types and configurable performance characteristics. Three important measurements are IOPS, throughput, and latency. IOPS means input-output operation per second. It measures how many storage operations can be completed each second. IOPS is particularly important for workloads that perform many small reads and writes. A transactional database is a good example. A database may continuously read the customer records, update account balances, write transaction logs, modify indices, create new orders. Each of these actions may generate multiple storage operations. Throughput measure the amount of data transferred over a period of time. It is usually expressed in a unit such as megabytes per second. Throughput becomes especially important when working with larger sequential files. Example includes video processing, big data workloads, backup operation, log files, analytics datasets. A workload can have a high IOPS without transferring enormous amounts of data, or it can have a relatively a few operations that transfer very large files. Therefore, IOPS and throughput are related, but they are not identical. Latency measure how long one storage request takes to complete. Lower latency is generally better, especially for interactive application and databases, where the application waits for each storage response. The goal is to select the current balance between performance, capacity, reliability, cost. This is known as right sizing. Over-provisioning creates unnecessary expense, for example, paying for extremely high storage performance that the application never uses wastes money. Under-provisioning can be equally problematic if the EBS volume cannot support the required IOPS or throughput. The storage layer may become the bottleneck that slows down the entire application. Good cloud architecture does not mean always selecting the most powerful option. It means selecting the option that matches the actual workload. We're going to the slide 10, EBS snapshots, backup, copy, and recover. Persistent storage still needs to be backed up. Persistence protects data from disappearing simply because an EC2 instance stops. It does not automatically protect against accidental deletion, file corruption, application errors, ransomware, incorrect configuration, volume deletion. Amazon EBS snapshots provide the point-in-time backups of EBS volumes. A snapshot represents the state of volume at a particular moment. The first major use case is backup. Organization can create a snapshot manually or automate them according to the schedule. For example, a company may create hourly snapshots for critical data, daily snapshots for standard systems, weekly snapshots for long-term retention. The second use case is restoration. When recovery is needed, a new EBS volume can be created from the snapshot. That volume can then be attached to an EC2 instance. The third use case is migration. A snapshot can be used to create a volume in another availability zone within the same region. Then move the data to another region. The snapshot can be copied to the destination region and used to create a new volume there. This supports application migration, testing, disaster recovery, geographic expansion. EBS snapshots are incremental. After the first snapshot, later snapshots restore only the blocks and changed. For example, if you only 5% of the blocks changed since yesterday, the next snapshot does not need to duplicate every unchanged block. However, from the customer's perspective, each snapshot can still be used to restore the complete volume. This gives AWS storage efficiency while preserving a simple recovery experience. One final best practice is important. The backup strategy should include recovery testing. Creating snapshots is not enough. Organizations should periodically verify that the snapshots can actually be restored and that the application can successfully use the recovered data. The slide 11, EBS benefits in real architecture, Amazon EBS. Amazon EBS supports several practical architectural patterns. Database hosting, EBS is commonly used for database engines running in EC2. The EBS volume may contain database files, transaction logs, indexes, configuration data. Database benefit from EBS because it provides persistence and low latency block storage with a configurable performance. Data migration snapshots make it possible to recreate the volumes in another availability zone. They can also be copied to another region. This is useful when moving workloads, creating contest environments, or preparing disaster recovery location. EC2 instance changes because EBS storage exists separately from each two instance. Changing the compute environment does not necessarily require recreating all the data. An organization can upgrade from a smaller EC2 instance type to a larger one while retaining the persistent storage. This helps separate the scaling of compute resources from the management of stored data. Disaster recovery automated snapshots can provide recovery points if the original data is damaged or becomes unavailable. Across region copies can support recovery from a serious regional event However, remember that EBS snapshots are only one component of a disaster recovery. A complete strategy must also consider EC2 configuration, Amazon machine images, networking and security groups, identity permission, DNS, databases, application dependency. Cost optimization. EBS volumes can be adjusted as application needs change. An organization may modify volume type, capacity, IOPS, throughput. For example, a new application may initially be configured with high performance because its requirements are uncertain. After monitoring the real usage, the organization may discover that the volume is over-provisioned. Reducing unnecessary performance can lower costs. The opposite can also happen. If the business grows and storage become a bottleneck, EBS configuration can be increased to support the new demand. This flexibility is an example of cloud elasticity. So I'm going to finish with the slides 12. We finish with exam ready decision guide. Let's finish with a practical decision guide for the exam of Cloud Practitioner. Temporary local speed, when the question mentioned cache, buffers, scratch data, temporary processing, recreatable information, extremely fast local storage, the likely answer is Amazon EC2 instance store. Okay, the important conditions are that the data is temporary and that losing is acceptable. Persistence disk for EC2. In this case, when the question mentioned a data running on EC2, a persistent operational system disk, application files, a traditional file system, data that must survive stop and start, the likely answer is Amazon EBS. EBS is the persistent virtual disk associated with EC2 workload, backup, copy, or recovery when the question mentioned point in time backup, incremental backup, restoring EBS volume, creating a copy in another availability zone, copying data to another region, disaster recovery. The likely answer is EBS snapshots. Here is the final memory hook. Instant store means fast and temporary. Amazon EBS means persistent value virtual disk. EBS snapshots means backup, migration, and recovery. Before choosing a storage solution, always ask 3 questions. First, must the data survive when an EC2 instance stops? Second, can the data be recreated if it is lost? Third, what level of performance does the application requires? If the data is temporary and recreatable, instance storage may be appropriate. If the data must persist, Amazon EBS is usually the better choice. If data must be protected, copied, and restored, use EBS snapshots as part of the backup strategy. Thank you for watching this lesson on Amazon EC2 block storage. In the next lesson, we can explore EBS volume, types, and snapshots, and other AWS storage service in greater detail. Thank you so much. See you soon.